And welcome to this lecture on Bayesian inference. So let us continue the discussion on Bayesian inference. So in this lecture, I will try to illustrate the usefulness of Bayes' theorem with the help of a couple of examples. So in Bayesian theorem basically used to solve a set of problems whose answer is in the form of a process associated with certain probability parameters is being used to generate the data. So some process is being used to generate data. So this process is associated with some probability parameters. So traditionally these type of problems were called inverse probability problems. Inverse probability problems, right? So let's consider an example where we can illustrate the usefulness of Bayes' theorem. So recall that Bayes' theorem that we have defined as probability of the hypothesis given the data is equal to probability of data given hypothesis multiplied by the prior probability of the hypothesis divided by the marginal probability of the data. So this is our Bayes' theorem. So let's consider two boxes. One is a red box and another is a blue box. A blue box, and we assume that there are a lot of beads in this box, colored beads. Let me draw some white beads. Some red ones. So the beads are in a mixed format. Some other colors also, right? So this is box red and this is box blue. So I'm drawing beads. So drawing beads from the box. So this box basically is not specified now. I'm picking beads, and I just saw that there are 3 white beads appeared in a row. So I don't know from which box actually I'm picking up the beads, and basically this picking up of beads is with replacement. So that means I just use the strategy of replacement, right? So whenever I pick a bead from box R or box B, I observe it, I make a note of that, and I replace in the same box, right? And the event that I have just seen is 3 white beads in a row. So this is my observation, right? And I know that probability of white beads from this box, red box, is 20%, and that of probability of white beads from the blue box is 10%, right? So these are the things. And now the question is, so when I see this observation, so question is, what is the probability of the beads drawn from box red or box blue? So I have to calculate the probabilities associated with box. So which box basically I'm picking, and I'm getting 3 beads in a row, right? So I hope the problem is clear to you. Let me go ahead with this. So let us write down the information that we have. So let me denote the parameter associated with the boxes. So without knowing that knowing the fact that from which box the beads are picked, so the probabilities are probabilities of getting 3 white beads in a row is 50-50. From it could be from red box. So I denote it as P theta of R is 50%, and P theta of blue is 50%. So this is the parameter associated with the red box, and this is the parameter associated with the blue box. Basically, the process is picking up beads, and the parameter associated with the probability is, or the distribution is, basically represented as theta, right? So let's try to apply Bayes theorem. So Bayes theorem, I can write it as P probability of parameter associated with red box given the data is equal to probability of data given the parameter and theta divided by probability of data, right? So so what is the data? Data is basically I have observed 3 white beads in a row, right? So let's see. So what is the probability that three white beads are drawn from box red. So what is this? So we have seen that picking a white bead from the red box is 0.2, right? So picking 3 white beads in a row from box red is 0.2 multiplied by 0.2 multiplied by 0.2, and this will be equal to 8 divided by 1000, right? So so what about the same question about box B? So that will be 0.1 multiplied by 0.1 multiplied by 0.1 equal to, so this will be equal to 1 over 1000, right? So this theta r given data is equal to so this is probability of data given the parameter theta r is been computed now. So this is 8 by 1000 multiplied by probability of theta r is basically half. So before, so this is my prior belief, right? Before I observe the data, divide by, so what is P of D? So this will be probability of D given theta of R, right, multiplied by P of theta R plus probability of data given theta B multiplied by probability of theta B. So basically this is the sum of all possible distributions of theta, right? So what is this? This is again 8 divided by 1000 multiplied by half plus 1 divided by 1000 multiplied by half, right? So if you compute this, you will get so this half and half will go cancelled. So this will be 8 over 9, right? So this is the probability of getting 3 white beads in a row from the red box. So what about the other one, theta b of d? So this will be, I can compute this in a similar way, but as we know, we can compute this from 1 minus 8 by 9. So this will be 1 by 9. So this is the probability associated with drawing 3 white beads in a row from the blue box, right? So this is how you compute the probability associated with the using Bayes theorem, right? So now let's consider another case where we use Bayes theorem. We use Bayes theorem to update the probabilities. So in the previous class we have discussed how the probabilities are being updated. So that is the major application of Bayes theorem. So now the same problem. So I'm going to draw one more bead, and it happens that the bead is again white, right? So now I can compute the probabilities again. So in the previous problem, the prior probabilities were computed. The prior probabilities were 0.5. Choosing 3 beads from blue box was 0.5, and that of red box was also 0.5, right? So these were the prior probabilities of the previous problem that we have computed, but we computed the posterior probability, the posterior for picking the 3 beads in a row as 8 by 9, and that of blue was computed as 1 over 9, right? So this will be now used as prior probability to the problem, right? So you can compute probability associated with let's say box red, given basically 3 white beads in a row, followed by and a fourth one, right? And a fourth one. So this is what we have to compute. So let's see how we can compute this. So this will be equal to what? So let's probability of a white bead given the box is red, right, multiplied by the prior probability. So what is the prior probability? So let me write it as prior divide by probability of the white bead from the box red multiplied by the prior plus probability of white bead from the blue box multiplied by the prior associated with the blue box, right? So this is red. So these values we have already computed. So this is 8 by 8 over 9, and this is 1 over 9. This is also 8 over 9, right? So so let's compute that. So 0.2 multiplied by 8 by 9 divided by 0.2 multiplied by 8 by 9 plus 0.1 divided by multiplied by 1 over 9, right? So this 0.2 is basically, we know, drawing, what is the probability of drawing white bead from the red box, right? And this is probability associated with the drawing a white bead from the blue box, right? So this is this we can compute. So this will become around so this will become 94.12%, and so the other one will be 5.88. So this is probability associated with the bead is taken from the blue box, right? So earlier we got 8 by 9, so that is around 88.9%, and 1 by 9 is around 11.1%. So you can see the difference. You can see the difference here. So earlier the probability of picking up 3 white beads in a row from the red box was 88.9%. Now if you pick another bead and it happens to be a white bead, and the probability associated with that is 94.12. So this probability goes up, right? And here the probability of picking 3 white beads in a row from the blue box was 11.1%. Now picking another bead, and which will happen to be a white bead, is now become 5.88%. So probability value goes down in this case, right? So I hope you understood the problem and how the Bayesian theorem is used to update the probability values, right? So this finishes this lecture. Thank you.